How's everybody's weekend? Short. Short. Yeah. Did I get in trouble? No, I stayed out of trouble. Breakfast.
Great still frames.
There we go. That's better. All right. Yeah. Friday, some of you were supposed to take the trig quiz, right? Who all still needs to do that?
I took mine on Friday.
So like Garrett and Jose.
Say Eric or Garrett?
Garrett.
Yeah.
So you don't have to. Wait a minute. Yeah.
It's over the same type of stuff as the brackets were, right?
Yeah. It's just solving triangles.
All right. Yeah.
And some of you were going to redo the trig homework. Have you done that?
Yeah, I did that too.
Caden?
Yeah.
What?
I said yeah, I retook the homework and did the quiz.
Okay. So the way I understand it is only 2 of you need to take the trig quiz. Is that correct? Does anybody else need anything else? Okay. We'll do that after the lecture today. I'm going to show you a couple different kinds of bends today, enough to get in the lab and do some conduit bending. And then after I show you the different kinds of bends, we'll get into some code that has to do with conduit bending after that. And then eventually we'll have a conduit quiz. So where did Zoom go? Oh, conduit. All right, this little picture on Blackboard shows you the different kinds of bends that you're going to have to do, but I have to check these numbers to see if they match what I actually want you to do. You're going to need to do a stub 90. Let's see if I can blow this up. There we go. It's these guys up here. 9-inch stub, back-to-back 90, an offset, a 3-point saddle, and a 4-point saddle. So those are the stub 90, the back-to-back 90, the offset, the 3 and the 4-point saddle. Those are the 5 different kinds of bends that I want you guys to be able to do when it's all said and done. So today I will show you. I think we could get all of those in today. And I think I'll split them in half. Yeah, I'm going to do that. All right, so there's 5 bends, and then you see this last column here says at least one of those has to be on 3/4 inch EMT. The vast majority of the bends that you would do, like, I guess it depends on where you work, but if you end up conduit bending a lot for your job, but this is useful stuff to even have like at home if you're running stuff in your garage or whatever, you can run conduit to safe it up. But the vast majority of what you'll do is on 1/2 inch EMT, which is what I'm going to demonstrate in front. It's a real small steel conduit that uses set screw or compression type couplings and fittings on it. But it's really easy to bend. It's easy to manipulate. And then if you have bigger wire, so bigger current, bigger load applications, you might need 3/4 inch conduit, and then on up the road, depending on what the application is. We'll get into conduit sizes and conduit types later on, but for now, I just want to show you the different kinds of bends so you can get started on labs. But I'm going to demonstrate 1/2 inch EMT in the front, and then one of your labs needs to be with 3/4 inch EMT, 10-4, and then there's a couple other, I'll get to that later. So, stub 90. I got to figure out how to do this to where the people at home joining us from the interweb see too. I hijacked your screens. Yeah, that'll work. Any of you ever run conduit before? Pulled it apart? You never bent it, like installed it? All right. So step 90 would be if I want to make sure I'm on camera here. If I'm running, a lot of these are going to be like, if I'm running conduit along this shelf, but usually you're going to be running along a wall or in a ceiling or something. We got, basically the point is we got to get wire from point to point, right? We can't just free it. So I'm running conduit this way along this little shelf, and then I got a box that I need to come up and into right yonder. Anybody have a tape measure with them? Freaking tool carts next door, and I'm too lazy to walk all the way down. Thank you. Okay. So if I'm running along this shelf, and I need to bring a 90 up into there, up into the bottom, and then there would be a little fitting down here, right? I need to measure from the bottom of the shelf or the bottom of where the pipe would be up to the bottom of the box. So the pipe is basically going to go in that fitting. Okay. Stub 90. So I'm getting, let's see, 9 3/8. So basically the distance from there to there is 9 3/8 inches. 10-4. Now what we need to know is when I put that thing in the bender and I end up putting this little radius on it, I can't take my flat piece of pipe and mark it at 9 3/8 because that would infer that when I'm done bending it, it looks like this. And our 90 is not going to look like that. It's going to have this little radius. So we need to know what that radius, the radius of that bend is going to take up. And that's actually called take up. It always has to do with the radius of the bender that you're using. On hand benders, there's a standard. For a 1/2 inch EMT, the take up is 5 inches. And for a 3/4 inch EMT, the take up is 6 inches. And most good benders will say that on there somewhere. This one says stubs 5 inch to the arrow. I guess we're on camera, so we'll do this. Right here. Stubs 5 inches to arrow. You guys have your Uglies books with you? All of these bends that I'm going to show you and the trig that we did before is in your Uglies book. So this is a good reference. I'm also going to give you a reference sheet that's on Blackboard, but you can use that on the quiz. 90-degree bender EMT using page 169. So on page 169, this actually shows you how to bend a stub 90, and it shows you how to do a back-to-back 90, which I will get to next. But it even shows you which mark to put on there. So 1/2 inch EMT, the take up is 5 inches, 3/4 inch is 6 inches, 1 inch EMT is 8 inches, and 1 1/4 EMT is 11 inches. Everybody see that? Huh? Yeah. I've seen 1 1/4 EMT bent by hand on video, but never in the field. There's a very large fat man doing it because you need a lot of help, gravitational help to get that done.
I almost can't do 1 inch.
You almost can't do 1 inch? I do 1 inch every morning, right when I wake up. So 1/2 inch. This is all EMT. Sub 90. So 1/2 inch is 5 inches. 3/4 inch is 6 inches. 1 inch is, help me out, 7, 8 inches, right?
8.
1 1/4 is
11.
Damn. So what that means is that the radius of this bend, what it takes up is, that's the start of the bend, and this is the start of the bend. This distance is, for 1/2 inch EMT, that'd be 5 inches. Make sense? So if I know that the radius of this thing is going to take up 5 inches, where would I need to bend, start the bend of a 1/2 inch EMT pipe to get it to end up right at 9 3/8 inches?
4 3/8.
Yes, sir. So when I mark my flat piece of pipe, I actually need to mark it at 4 3/8 inches so that when it radiuses up, radiuses, is that a word? Then it will end up right at the bottom of that fitting. And when you're thinking, me, that's amazing. Is that really true? It's gonna happen? I'm gonna tell you, yes, it is gonna happen.
So then when you say starting your curve, you're gonna start it on the short side, you're not gonna start it on the long side?
Right. So if this is 4 3/8 inches,
That's the part that's gonna.
it's gonna
stick
start to
straight.
bend
Platypus.
right there, and then 4 3/8 inches is gonna stick out.
Alright,
And then where that straight part ends up is the other 5 inches.
gotcha.
Does that make sense? So I have very easy, efficient ways to cut pipe. Because I'm fat and lazy, but you guys are going to use this tool. Did you use one of these before?
So one of the other one.
All right, the important thing to know for these is that the teeth, a lot of people don't even know this and use this before. That was the dean of the college. Just kidding, that was grandpa. The teeth on these things face forward. Did you know that? So all the cutting on these things, the cutting motion is when you're pushing forward on it. And if you get on there and you struggle with it, everybody does when they first start using hacksaws. But I would normally use like a Sawzall or I don't know, we call it pipe
So I can
cutter.
bring my Sawzall in?
Huh?
I can bring my Sawzall
No,
in?
you must use a hacksaw. Pipe cutters?
Yeah.
But you gotta be careful because this isn't copper, this is steel. So it's not like a plumbing pipe cutter. If you get one of those, you probably bust the cutting wheel on it pretty quickly. So, but yeah, you do. I actually have there's a Conduit pipe cutter back there. It's enormous, but it's for steel conduit. But you wouldn't want to use that big giant thing on this tiny little pipe anyway. You'd get it done a lot quicker if you just cut it. So, and I'm not cutting this with a specific spot. I'm just getting in there and getting after it. All right, well, the next thing that I want you guys to get in the habit of doing is if I don't need to make a band, I just need a piece of pipe that's long to keep going with my pipe run. And I put that on the wall, put a coupling on it and keep going. You think those little burrs in there might make some problems?
Yeah, your wire.
Yeah.
Jason.
So I was always taught, file it until you fuck it. And you guys probably
Was
would,
it hand reamer?
yeah, you probably don't have these. I'm gonna leave this back there and hope that it doesn't disappear. You're welcome to use this, but please, when you do your lab, bring it to me and show me, hey, this is my whatever, 8-inch of 90. And when I look at it, I'm gonna check to see if it's reamed. This is called a reamer. You need to ream those burrs out. You can use this. You can use a file. This one is a little bit too big for a 1/2-inch EMT. But you guys know what Kleins are, or side cutting pliers. Those work just as well to put those in there and ream it around. But this will be available to you. So it's got these little teeth for each different size of pipe. This is only for EMT. You stick it in there and you just make it a bitch. You know what I'm saying? It's not working.
Spin on it.
So we put a kink in it. Then a kink in my pipe. There it goes. Oh my goodness. If you're on a job where you're running a lot of EMT, you're going to do this quite a bit at home in your garage, I would get one of these. They're very handy. So, all right. I have filed that until I would F it. So I'm ready to go. But I'm going to leave it in there whilst I take my measurement. I'm going to take a measurement so people can see me. So where do I need to make my mark? 4 3/8. 4 3/8. So I need to come up 9 3 inches. I have a 5-inch take up on my bender. So I'm going to go 4 3/8 and make a mark. 4 3/8 or chunker. All right, real life conduit bending, you use a pencil and not a Sharpie. I don't care if you use a Sharpie in here. Matter of fact, it might even be a good thing. Because then when I transpose this mark all the way around and I'm messing the funnel in the pipe, it won't get rubbed off. But in the field, why you'd want to use a pencil is that's one of the reasons is that, oh crap, you're going to make mistakes. You're like, wait a minute, that's wrong. You just, do that. Yeah, like that. Okay, Garrett does it perfectly. All right, you got practice, haven't you? Just kidding. Now this one, I'm only doing one bend on this, so I don't need to transpose it all the way around because I can use that mark and then I'm done. Okay, 4 3/8. Look in your uglies book and tell me what mark on the bender I'm supposed to put that on. So you got all sorts of marks on this thing.
The arrow.
The arrow, which is, survey says right here, okay? Most of your bends to start with, you're going to use the arrow. The arrow indicates the start of the bend or the start of the radius. But you will use all these marks in this class in your labs. But if you look inside the shoe, you can kind of see that arrow lines up with where the start of the bend actually starts to happen. So when I put that mark on the arrow and then I bend it up 90 degrees, it's going to end up hopefully right at 9 3/8 inches. Okay, the 90's, the Uglies book doesn't show this, but you're actually going to put this one on the ground and bend it up. But I start every single one of my bends in the air. What I mean by that is with the bender standing up. So I'm going to put it in there and line it up on my mark and just show you what that looks like. See that?
Mm-hmm.
Whoop. Be careful where the end of your pipe is. And then, yeah, you can see. Okay. All right. Push down and get the bend started. So you see what it looks like so far. Yeah, okay. And then I shall put it on the ground. The reason that I do this way is because if I put it on my mark without having made that bend and then go to set it on the ground, it tends to move. When you bend it a little bit first, it tends to stay in place a little bit better.
What's the matter with making the whole bend with the end of your bender on the ground?
Like this.
Yeah.
I could try it.
Seems like you have a lot more leverage.
Try it. No, actually, we have more leverage with it on the ground, but you're just not quite going to make it. Okay, and you can do it, but eventually you fight it. And what you find when you're making these bends in the lab on your other ones, where all of the bends are made in the air, is that the bottom of the bender is going to start to go whoop and slide out from underneath you. So if you're trying to make that huge bend like that, eventually it's going to start sliding around.
First of all, for some reason, that thing is longer than that. It's very impossible.
Right. Yeah, I suppose if it was a really short one, you could do the whole thing in the air, but I'm just in the habit of doing it this way. And I usually don't bend it that much. I just give it a little slap and tickle and then put it on the ground. And the slap and tickle is just to keep it in place. All right, so then you want to put your foot on this little part of the bender and push down at the same time. And the reason you do that is if I just push down on the end of the handle, do you see what starts to happen to the pipe down here? It starts to bend a little bit up and you'll get a little whoopty in your pipe. If you put pressure down and bend until you just barely feel the end of the shoe hit the pipe, you should be pretty close to 90 degrees. And I actually overbent that a little bit. Can you see that?
Yep.
So the good thing about half-inch EMT is that it's really easy to fix that. And how you fix that is put that in there and go, oh. Pretty good? Yeah? It's still a little overbent to me. It's more better. And if we did that right, should fit right at the bottom of that coupling. And I will take take your round of applause now. Keep going, keep going. Thank you. Okay.
You got too excited.
Take a bottle. Okay. That is a stub 90. Back to back 90. Back to back 90 would be if I've got another box, say here. Another fitting here. And do me a favor, if I'm doing something and you can't see it on the screen, can you just tell me so I don't have to keep doing that to see if I'm doing it right? Yeah. All right. So if there's a bunch of shit in the way, okay, and I can't just go into there, you'd use a back-to-back 90. The goal is to make it look like that. Now, I already know what the take-up is, so I could find this measurement here and go back 5 inches and then bend it up. But the proper way to do it is to use the star. It's actually quicker. The star on the bender. Wait a minute. Yes, the star. The star on the bender is right there. Okay, and there's, by the way, there's other guides and videos that I'm gonna put on Blackboard for you guys to do. And you got, this is gonna be on YouTube, this lecture. So when you're going back to do it in the lab, I really don't want you to come and tell me, hey, how do you bend my stub 90? I'm not gonna go through this whole thing again, right? Because you guys are taking notes and stuff. You know what I'm saying? Okay, anyway. The star, and what I'm aiming for is the tip of the star. Okay, there's a long tip of the star. Any bender you have, this is an ideal bender, and then Klein makes some, Greenlee makes some. There's going to be a star on there, and that is the point that I'm always looking for, is the tip of the star. The tip of the star indicates the center, no, the back of a 90-degree bend. So if I measure that distance from the end of this 90 to the end of this coupling, put that mark on the star and bend it up, it should bend right up to the outside of that coupling. The most important thing to remember for back-to-back 90s is your measurement is outside to outside. So this outside of that coupling to this outside of this coupling. 10-4. Most of your other bends, you're going to be measuring center to center or bottom to bottom. This is the only one that you're doing outside to outside. Okay. So you can take that off of there. We'll do some measurizing. Might as well show you the proper way to do it. So I need to measure from that line over to the right edge of this coupling. And that will be my schmear. Left-handed one. So I always kind of started out with 10. It looks like I'm at about 44 and 7/8. So that would be 34 and 7/8. Why do I start on the 10?
For the 5 inches to take that.
No, because this is kind of like what a third grader would do with a tape measure. If I had something to grab on there, of course I would, or if in the field, if this was already mounted, and I had my level standing there, I would just grab it and pull it over and look at it. But, what did I say it was? 10 to 44 and 7/8, so that'd be 34 and 7/8. Like it? Love it? Want some more of it? Okay. There's Did y'all see how I had to kind of fight holding that level there and measure? Okay. On the wall that's behind Will, there's a piece of unistrut. On the other side of it, there's a piece of unistrut mounted to the wall. It's perfectly level. You don't believe me, do you? You're gonna go look.
You want me to get it?
It's bolted to the wall. Bolted to the wall perfectly level. Okay. Then on one side of it is another piece of unistrut bolted to the wall perfectly plumb. So if you had a 90 already made up, you could shove that right up against that strut and then measure over and make your mark. I think there's even a measuring tape on there.
Yeah, there's.
Because I'm that awesome.
Thank you.
You're welcome.
Do people that do Conduit carry around squares with them?
Some might, but a lot of places will have like a table that's got that same setup, a strut, and then another strut at a perfect angle. So I've made my mark on there, and then what I need to do now is transpose that. What I mean by that is make it go all the way around the pipe. The best I can. The smaller the line, the better. Because when I do this, I'm going to put it on the spot on the bender where my mark probably would not just happen to line up. Okay. This is the part that I always.
Star goes on the line.
Star goes on the line, but the shoe. See, they've got the second bend going on the arrow, and that's not right. The most confusing part about conduit bending, and since it's been a year since I've done this, I don't remember, is where to have the shoe face.
Our shoes that roll.
All right. I believe that's right. Let me look it up so I don't screw it up. This is a good PDF for you to look at as a reference, hand bending conduit. Back to back bend. Mark the raceway here and use the star. Now they've got the shoe facing towards the outside. When I say shoe facing, the part with the little hook, that's the front of it. So I need to have the shoe facing towards the outside, which I've already got. So my habit of conduit bending is right. So what that means is that if I got my mark on the star, if I had the shoe facing this way and bent it up, it would not end up at 34 and 7/8. balls, make sure you got the shoe facing the right direction. Get in there. Be close to the star. Just a 3/4 inch. Anybody catch that?
3/4 inch.
So I'm on the mark, and then what I want to do is eyeball it the best I can to get the first stub as close to lined up with the handle of the bender that I can. Otherwise, it will put what's called a dog in there.
They're off center.
When you look down the end of it, instead of lining up, they go like that. That's called a dog. Pretty close. The same thing, I'm going to start the bend and then put it down on the ground and finish it. Pretty good. Yeah, and if I did that right, it should land right on the couple there.
If you're doing that in the field, you just cut the pipe off.
Sure. Pretty cool, right?
Well, I don't know.
So yeah, 1/2 inch EMT is very easy to work with. So then at that point, you would make a mark right there, cut it, ream it, put it in.
Look, everybody else say it's a little short.
On the right, yeah.
A little bit. I was looking at.
Is that better?
You're like, yeah, there you go. That's centered up on the right side.
So maybe this is a little like that. Is that
Yeah,
better?
yeah.
Are you freaking Siskel and Ebert? Yeah, so this one might then have been just a little bit overbent, so it didn't, okay. If the measurement's right, it's right, but it actually does look like it's a little overbent still, so. Better, Ebert?
Yes, absolutely.
Okay. So that is a back-to-back 90. When you do your lab, you need to, that's not it. You need to do a stub 90 that's 9 inches tall. And you need to do a back-to-back 90 that's 9 inches tall on the stub and 32 inches apart. So where I just did 34 7/8, you need to do 32 inches apart. Then it says 9 inches tall and 32 inches apart. You don't have to cut that down to 9 inches. Show me this, show me that it's 32 inches from this side to this side, and then that's good. All right. So you bend your first stub 90, and then you can use that same piece of pipe to do your back-to-back. Corey?
So you couldn't use the arrow for both sides if you wanted to?
Could you? Yes. Why wouldn't you want to?
That's not
It's not that it's not the proper way. It's just you have to do extra math. Yeah. It's not that hard of a math, but
Yeah.
if you know the distance apart, like you're going to have to know the distance apart for either way you bend it.
Yeah.
With your method, with the take-up method, then you have to measure back 5 inches,
Oh,
put it on the
okay.
arrow, and bend it up.
So the stars is basically.
The star helps you skip a step,
Okay.
right? Does that make sense?
Yeah.
Okay, so that's a back-to-back 90 offset. All right, here's where your triangle starts coming in. This one has a fitting right here. And in order to keep my bends down in the conduit, my bend degrees, I'm gonna do the same thing, but then I'm gonna come up at 30 degrees and offset in. What do I mean by keeping my degrees of the bends down?
Small degrees instead of like 90 degrees.
Yeah, why would we want to do that?
It's easier to shove wire.
Shove a full wire. You're allowed by NEC, and it's in the PowerPoint that I'm going to show you. You're allowed 360 degrees of bends between any two pulling points. So if I had another, if I'm going from this box here, if I went out here and then down and then over and then down and then over, that's 90, 90, 90, 90, 30, 30 for a total of 420. That's a lot. So that's against code, but I mean, kind of common sense too. Would you want to pull wire through that? It'd be a bitch. But if I went like this, and over, that'd be 90 plus 30 plus 30. Even better, would just be 90 and straight over. But I'm not coming from this junction box. I am coming from way down here. And not just the pole wire, but that first one that I drew that had 420 degrees of bend in it. Could we get that wire in there? Yeah. But eventually, the more pulling force you're pulling on that wire, you're going to start to compromise the insulation of the wire. Right? Okay. 30-degree offset. So I got a triangle. 30 degrees. And I need to know, right, my pipe's going to look like this. I need to know how far apart to make my marks on the pipe, right? So what do I need to know? What can I measure in this situation?
So I follow your little portal junction on this ground.
And that's called the offset height. So offset height is from the bottom of wherever your conduit's coming from to the bottom of your fitting. I always tell people to keep in mind, think about it in terms of you're trying to go over something that is how tall. So if this was a, I don't know, basketball. Okay, and I need to measure this anyway, but from bottom to bottom, that's your measurement. So I'm going to call that, I'm going to call it 10 inches. So this is a 10-inch tall basketball. I need to go up and over 10-inch height. So if I know this is 10 inches, I know how far apart my marks need to be. Now that we're trig experts, yes, you have your hypotenuse and your base. So relative to the angle, what's step one? Find the punk.
Yeah.
Relative to the angle, I have an opposite. I'm trying to find the hypotenuse. So it's sine. So sine 30, step 2.
Yes, sine 30 equals
And I bet it happens to be 5 if you put that in your calculator. I will tell you in a minute how I want to finish this bend, and I'm going to tell you in a minute how I do it. Okay.
You just, yeah, that's probably what you do.
Yes, but it's also something called a multiplier, which is just give me a minute. What am I doing? So I know that my marks need to be 30 or 10 inches apart or 5 inches apart here, right? But I can't start my bend with the arrow on the on the bender, right here, I have to come out a little bit. In other words, I need a little bit of flat space to start with before I start that first bend. You can make that whatever you want, but it's basically on your bender, you need at least,
How does that make any sense?
What?
The hypotenuse is 5. Because I thought the hypotenuse always had to be longer than the side.
yeah, it's 20.
I do 5. Yeah. When I did the math, I got 5 also. We did something wrong.
It's off.
Yeah.
Yeah.
Okay. I was like, yeah.
Man, you guys really screwed that up.
I know rage.
So H would be 10 divided by 0.5 percent.
Yeah.
Equals 20.
Yeah. 5 inches. Don't forget the last step. Doesn't make sense.
That's right. Step 5. Does it fucking make sense? Okay. Give me another stick. For all these first few laps where you're just bending 90 back to back stuff 90, you're not going to need any more than 5 foot conduit. So I would just take a stick of pipe and cut it in half. Okay, you use half for your shear. Measure it, and just guess it. And this bender is going to be over in the back corner where all the conduit's standing up, and there's some workspace back there. There's some tables you can use to work off of. So when you're cutting pipe, put your safety glasses on to people walking by. Better make it look like we're trying to be safe at least. Some teeth on this thing.
So how will it stream out? Is it based on your?
Pilot until you enter. Exactly. So if you don't care, if your insulation gets a little gnarled up, just go ahead and leave it. All right. So where am I measuring this at? Started to tell you a second ago.
20 something.
Not take out. What you're thinking about is shrink, and eventually we will get to that because the pipe, as you bend, it will start to shrink back towards. But if I put the bender right on the end of the, can't do it with that vice on my foot. I put it right on the end, so my hook is right on the end. My arrow is not on the end of the pipe, right? My arrow is right there. And it's like 3/4 of an inch or something. But I have a standard in my head. What I always use when I'm bending conduit is I come out 2 inches and I go. That's just my standard. You could make it 1 inch, 1.5 inches, whatever you want. You just come out a little bit. It doesn't really matter. But there needs to be a little bit of a flat space right there before you start the bend. Otherwise, you're not going to be able to fit the pipe in the chute.
So when you're doing conduit, all your boxes are in place and you're doing conduit afterwards.
Can be. In this case, a hard one to answer.
It's just depending on the situation.
In this case, this little box offset there, this person had a height they wanted, so they had to hit that. But if I was just going to add another box over here somewhere, I would bend an offset, put the box on the end of the pipe, and hold it up there, and then screw the box in. You know what I mean? It just depends on what you're running where, and you'll get kind of a system that you like to use as you go. Okay, so I'm gonna come up 2 inches, and then how far apart do my marks need to be? 20 inches apart. So I go to the second mark, I need to transpose that all the way around. See why I'm not. Because both marks, both bends, I'm going to use the arrow on the front. I'm going to bend them down to 30 degrees, and then I'm going to bend second. On my first mark, put it on the arrow. That's 2 inches from the part. That's just my thing. But as long as you got enough room to where the end of the pipe is not sucked back inside of the shoe, you're good. So it looks like it's about 3/4 of an inch. But my standard is 2. I don't know why I just always done it that way. All right. Bend down to 30 degrees. And as I'm doing that, see how I'm grabbing it kind of closer to the bender? I'm not going all the way back here. Same reason you put your shoe on, or your foot on the shoe when you're bending a 90. You don't want to put a big hoop deep in there. So as close as you can get it to the shoe, where your weight can actually make happen what you want it to happen. And then what I'm looking for when I bend this is that the bottom of the pipe ends up with a line associated with 30 degrees. So I'm going to bend it down, and I'm going to put it on the camera so you can see it. It's pretty close. I want you to see what it looks like. Okay, you see how the line associated with 30 degrees is parallel with the bottom of the pipe? That's what you're looking for. You want that line to be right lined up with the bottom of where your pipe is going. It was what? If it was on the floor, you'd have no way of telling until you lifted it back up. So you want to bend this one through the air no matter what. Okay, so this is actually a really quick bend when you're in the habit of doing it, but I just bent my first one and down to 30 degrees. What you do, you lift the end of the pipe up, push it through, so you get close to your second mark, and then you spin it 180 degrees. I'll show you that again. Okay, I just made my first bend down to 30 degrees, lift the end of the pipe up, push it through, and spin it 180 degrees in one fluid motion. Okay, then I look and I eyeball to make sure that it's lined up with the handle of the bender so I don't put a dog in it. And you understand what a dog is? Yeah. Okay, I'm going to bend this one with a dog so it's easy to see what that looks like. I'm going to purposefully put a dog in it. Right. So bend the second one down to 90 or 30 degrees. When it's 30 below, that's put it on down. Huh? When it's 30 degrees, you don't really have to put it on down. No, 30, 45, 22 and a half, none of them. You should do them all from the air. Because you can look and see what you're bending to when you're doing it. If it's on the ground, you can't see what you're doing. You're darn close. Yeah, there's a dog in it, but that's well, pretty close. And if I had a torpedo level, which I would recommend you guys bring in if you have one, it's just a small level. And I put that on there. It looks like that one might be. Is it running downhill a little bit? Is it? So what I can do is take a little bit out of that bend, or I can put a little bit more into this bend. Having GMT, it's pretty easy. Too much.
And the dog, do you think?
A dog can be fixed sometimes. Holy smokes.
They have like standards. Check that on it. Or is it just whatever?
What?
Like a standard that you can put on pipe, like squares, 90 degrees, and they have like 30 degrees.
On the pipe.
It's 30 degrees. They make
Oh,
square.
no, I've never seen it. It's something that's exactly 30 degrees, and you can put your pipe up next to it.
Yeah, as a reference.
No, I've never seen it. I mean, you could use a protractor. I have a digital one that you can put on there, and it might say 2 degrees, and that would say 32 degrees. You know what I mean? But okay, so that's pretty close. And having GMT, like as long as it doesn't look like shit, that's a little bit high. But if I put that in the coupling and then force feed it in my support, it's going to look pretty darn good, right? But our math was right. That's all I'm concerned about here. When you do your bends, it might have a dog in it. That stuff goes away with practice. But what I want to see is that your bend lines up with that 30-degree line. Your marks are 10 inches apart. Like you're doing it properly. Making it look good just comes with practice. But this is what a dog looks like. You see it? Yeah. So that's not lining it up with Benner. Now you asked, can you fix that? You can fix that one. Sometimes you can. Sometimes you can. More often than not, when you end up trying to fix a dog, it ends up making it look worse. The other thing that ends up happening is that you, you start to keep fighting.
Is it anything fancy to make a bend, or is it just regular tube steel?
Closer, but I'm starting to put kinks in, like little dents in the pipe.
Is there anything fancy in there, or is it just steel tube?
It's just steel tube, and then they have like a galvanized coating on it, so it doesn't rust. That's EMT, electrical metallic tubing, one of the most common forms of conduit used in the field. All right, one more thing before I cut you loose. So there's two ways to bend conduit with triangles. Okay, we talked about trig. There's the other way to do it called a multiplier. On Blackboard, if you look under the conduit section, there's something called a reference guide or something. You can use that paper printout on the quiz if you want to. But the other way of doing it is something called a multiplier. So what if, let's
instead of using 30s, we decided we wanted to use 45s. Yes, but it changes the distance on our marks, right? So in this case, our triangle would look like this. 45, 10. So what does that make our hypotenuse?
It's 45, 45, and then you don't, yeah, both the sides have to be the same. It's 10, 10.
Right, but wouldn't it be the same thing? H equals 10 divided by sine of 45.
And there's something to do with 45, 45, and then triangle, but the hypotenuse is always something to do with the sides. But you know, like the
It's
Pythagorean
probably the same as the multiplier. So let's get to that in a second. So we solve for this, what do we get? For H. 10 divided by the sine of 45. 14.142. So 14 and 8, somewhere like that.
8 does 1.25. More or less anyway, pretty close. It's pretty small.
All right, do me a favor and pull up that Conduit quiz reference sheet. Don't do anything until I do it for you. Conduit quiz reference sheet. I will print this off and you can use this on your quiz. Here's a little bit of trig. We talked about take up, 1/2 inch, EMT is 5 inches and so on. So that's for your stub 90s. And then this top part here, the trig is on the left, and then they have this hypotenuse multiplier. So 30 degrees, that multiplier happens to be 2.
That's how you need one of them.
Yeah. 45 degrees, the hypotenuse happens to be 1.41 times the height. So you use those multipliers to find the mark. So 30 degrees is 2. 45 degrees is 1.41. Do me a favor, what is 1.41 times 10? You're using the multiplier is 14.1. See how they're pretty much the same. The bigger your offsets get, if I had to go over a 15-inch height, trig tends to be more accurate. But in general, you can use those multipliers the same way. If you do any of these things, so let's say this was, let's make this 14 and 3/8, 14.5 inches. And let's make this 14.5 inches. And first we'll solve them with the trig, and then we'll solve them with the multipliers. And for these, all you're doing is that same sine formula. So it would be 14.5 divided by sine 30. And this one would be 14.5 divided by sine 45. So what do you get for each of those?
For 45, you get 20.506.
And 30? 29 inches? Perfect, like 0.0? Huh. Oh yeah, because it's times 2. All right.
Now use the multipliers. What is 30 is just 2 times the height with the multiplier. So if you're a multiplier type conduit bender, you go, okay, I got to offset over this 14.5 inches. I'm going to use 30s. So I'm going to take 2 times that, it's 29 inches, and I'm done. If you're a math guy, you're going to say, okay, so 14.5 divided by the sine 30 is 29 inches. Either way, with the multiplier, it's 2 times the height. So 14.5.
The multiplier type are more common. Multiplier seems quicker.
They're easier, but if you're like me, I don't bend conduit every day. So if it's a year from now and I don't remember what that stupid chart says, like I can write down a triangle pretty quick and figure it out. Right? That's why I'm more of a math guy. It always works out.
You said like that they really get your more error, I guess.
Right. So this one's a little bit bigger. Let's see how far off we are here. So what is 14.5 times 1.41? 20.445. So you're talking about a tenth of an inch difference, a little bit more. Not much. I mean, that's more than your pencil mark, right? Either way you do it in the lab, it's fine with me. I just want you to know how to do either one. So when you get the feel that you're doing this at home, you can be comfortable with one. Does that make sense?
What does the EMT cost to buy?
It's been a while since the prices of everything have gone up since old Biden took office. I don't really know. You look it up. Before I look that up, what does anybody have any questions on this stuff? Okay, if you want to bend conduit, there's all sorts of 1/2 inch and 3/4 inch EMT benders. There's all sorts of 1/2 inch and 3/4 inch EMT pipe in the back. If you want to do the drill station, I've got them pulled out, but I'm having issues with both of them. I have to troubleshoot. There's a couple drills that aren't cycling right, so I will probably work on that first. And other than that, just let me know if you have any questions. Ish? Okay.
So you're gonna give us the quiz now?